Hey guys, good evening. Okay, so back with another video. This is Module 3, Chapter 4 and 5. Right here is number theory and integers. So here, let's go ahead and get this party started. We're gonna start from the beginning, right there. Isn't it pretty? We got the blue. I like the blue. Okay. By me, Miranda Curtis. Okay, question 1. Use the divisibility test to decide which of the numbers 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 is divisor if we can go into it. Of the numbers in the left column of the following table, the number 684 is done for you. So we already have that one. Okay, I have to move my little screen because I wanted to go ahead. That way, if you're new to this part, you would know what the divisibility rules are, all the way 2 through 11. Okay, so they said that we already have 684. So it was already, it went in it. When it has an X, that means yes, and when it doesn't, it means no. So we looked at the 2 rule. It says if the last digit is 0, 2, 4, 6, or 8 is divisible by it. So we look at 684, and it was, and then 2064 right there, 4, and then we come over here. 5 plus 1 is 6, so we know that's going to be right there. That was not it because it's a 1. I was looking at the next one, sorry. Then we got 64490. There's 0, so it's divisible by 2. There's a 0 on our next one, it's divisible by 2. And there's an 8 on the next one, so we know it's divisible by 2. Now let's look at 3's. Okay, if the sum of the digits is divisible of 3, so 684 is divisible by 3. Sorry. Then we look at 2064 is divisible by 3. 51,051 is divisible by 3. And then we look over here, and this one is divisible by 3. But look at this one, 2676740 was not divisible by 3. You couldn't divide it into 3. It gave you like point something, something, something. Means it was not divisible at all. Okay, and then we go to our next one, 50250528. It was divisible by 3. When you divide into it, it gave you a whole number. Now we're going to look at 4s. If the last 2 digits is divisible by 4, then it's divisible. Our divisibility rule is 4. So our last number, 684, is 4. So we know it's going to be divisible by 4. Then we looked over here again, our next number, the last number is 4. We know it's going to be divisible by 4. Then we look at our 51051. It's not divisible by 4. Try to divide it in again, you get point something. Oh, then we look up here, even though there's 4's in here, it's not divisible by 4. I tried. Then we look over here and we got 2676740. It is divisible by 4 because 4 times 10 is 40. We know that. And it's divisible by 4, the last 2 digits, right there. It is. Oh, then we come to the next one, 5025058. 28 is divisible by 4, so we know it is. Okay, let's look at 5's. Okay, 5's rule is if the last digit is a 0 or a 5. So we look at 684. It's not. It doesn't follow that rule, so it's not divisible by 5. Then again, we look at 2064. Again, it's not a 0 or a 5, so no. Then we look up here. This is tricky because you got a 5 and a 1 at the end, but again, it's not divisible by 5. And we look up, oh look, 90. You guys know it, that 5 goes into 90, so you know it is. Oh, look, 4 goes into 5 as well. See, we got that one. But look at this one, the 2 in 28, it does not go into 5. I tried. So dot. Okay, let's look at our 6. It says if the number is divisible by 2, 2 and 3. Okay. Okay, look, 284. Yep, it's divisible by 6. It follows our rule 2 and 3. Then we come to our next one right here. It's divisible by 6. Sorry, these are 6s. Oh, 51. We look at this whole one. It's not divisible by 6. Then our next one right here, it is. It's divisible by 6. We're getting lucky. So far, he's been pretty divisible except for 4. Oh, look, our friend right here, he's not divisible by 6. Not by our rule, what we go by. He's not. Then we come down here to our friend right here, and he's divisible by 6. Okay, let's look at if they're divisible by 7. Cross off the last digit, double it, and subtract. Repeat if you want. If new number is divisible by 7, original number is divisible by 7. Okay, let's look. Oh, 7 was hard. There was a lot of no's in there. Okay, so we looked at this one right here. It's not divisible by 7. We did what the rule said, and it did not pan out. So nope. Then we look at this one right here. Again, this one didn't pan out either, so we got to know. Then, oh look, our friend finally got one divisible by him, except for 3. Now it's 7. So we know 7 is divisible. And then we look up here at this number right there, and it is. We have an X. Oh, but look at this one. Even though there are 7s right here, that's tricky. It's not divisible by 7. And then we look up here. Again, you might be like, maybe. No, we did what the rule said, and it's not divisible by 7. Now let's look at the next line. Let's look at 8. If the last digit is divisible by 8. Okay, let's go through. Okay, so the last digit. 4 times 2 is 8. We know that. So yes, that one's divisible. Oh, look, another 4. We know this number. It's divisible. 51. Nope, not. Let's look up here at this one. It's not divisible by 8. Look, right there. I know. You think maybe it will be because there's a 4 and a 0? Nope, it wasn't. Not divisible. Then we look up this one. Oh, look, there's an 8. We got that one. Yay, 8 got 3. Okay, let's look at 9. 9. If the sum of a digit is divisible by 9. Okay, let's see what we got. Okay, let's look right here. Oh, our friend right here, he's divisible by 9. If you thought this one is, you might have thought that one, but it's not divisible by 9. You got like point something. Oh, then we look at our friend right here. Even though these two are odd numbers, not divisible by 9. But look at 90. 9 times 10, we know is 90, so we know it's going to be divisible. Look, you might look over here and go, oh, that's a 9 and a 0. Here's another 0. Nope, 40 is not divisible. But look, right here, that is divisible by 9. Let's look at 10. If the last digit is a 0, think we're going to have a good amount of those? Let's watch. Oh, no, it wasn't as many as we thought there were. Is this one a 0? Nope, not divisible. What about this one? Nope, not a 0. What about 51? Is that a 0? Nope, we didn't have a 0, so it's not. But look at this one. Our friend right here got one. Here's a 0. It's divisible by 10. Plus 9 times 10 is 90. So we know that this is going to be divisible. Oh, is this our friend right here has 0? Yep. And then it's 42. So 4 times 10 is 40. So we know it's going to be divisible by 10. Then we look up. Does 8? Nope, not a 0. So we know that rule is right. And we can see that. Okay, let's look at 11. Subtract the last digit from the number formed by the remaining digits. If the new number is divisible by 11, the original number is divisible by 11. Let's see. 11. If you look up here, not going to be divisible by 11. And then our friend right there. But right here, we have this one. It's divisible by 11. We look up, we do got some 444s in there. We see it right there. So that's divisible by 11. We look up here. That's divisible by 11. But look, our big old friend at the end, you would think, because you see how it repeats a little bit here and it comes back and repeats here. Nope, it's not divisible by 11. So that's how we check to see by our divisibility rule. See, we have all of them right here. So if you need to come back to the slide because you have a question about divisibility rule, you got it right there, okay? Let's go to problem 2. There's question 2. Okay, use the process of 9 to check each of the following answer. I'm going to put my little help bubble up here to make it easier. So before we start solving, we have to read our help bubble. To help to solve the problem, go to the first line. When you see a 9 is crossed out, like our little example right here, you see 3, 6, 9, 9, 2, 7, you automatically cross out your 9s. That way, when you're counting, these won't count. You just mark them off, okay? The next step is to look to see if any of the numbers in that line add up to 9. If they do, mark them out. So we know 6 plus 2, wrong way, sorry. This needs to be marked over here. 7 plus 2, not 6. I'm a little tired today, sorry guys. 7 plus 2 is 9. So we're gonna mark out the 7 and the 2. That's wrong, that's supposed to be a 6. Oh, nope, that equals 9. Okay, then you add them up. Together, separate out the numbers. 3 plus 7 is 10. 1 plus 0 is 1. Okay, if that equals 9, you take it out. Okay, let's look at our problem over here. Do we have any 9s right there? No. Do we have anything that's going to equal 9? 6, 7. See, that's 7. 6, 7, 8, 9, 10. Nope. Okay, let's see. Oh, but we come down here and we have a 9, so we got to mark him out. Okay, 7, 8, 9, 10, 11. Nope. See, we're going to bring him over. Oh, there's a 9 right there. We got to mark him out. 6, 7, 8, 9, 10. See, nope. That one either. So what we're going to do is we're going to bring it over here. We're going to add it together. And this is how we're going to check to see if the problem's right. So 4 plus 1 plus 6 is 11. And then you're going to separate out. 1 plus 1 equals 2. That's going to be your remainder. Okay, then you bring this over after you take that 9 out. 7 plus 4 plus 0 equals 11. Now we're going to move it over. 1 plus 1 is 2, so that's our remainder right now. Okay, so we took the 9 out, made sure nothing else added up to 9. So 6 plus 8 plus 4 plus 2 equals 22. So we separate the 2's. 2 plus 2 is 4. Okay. Now we got to do this to the bottom too to see if that's right. So we see a 9 right there. 7, 8, 9. These two are gone. So that leaves us with 1 plus 1 is 2. So our remainder in the bottom is 2. Okay. So, and then when we add all this up, we go through and we add it all up. The correct answer is 77750. It is not this number, see? And we're going to see how this is a 2. And then we come over here and we get down to the bottom. You have to simplify out. So therefore it's going to be 4. It's 2 and 4. And they don't match. If they match, then it means your answer is correct. If they do not match, that means your answer is wrong. So cast out 9, show there's an error, because there is, and then the given remainders are 2 and 4, the correct answer. Okay, let's look at B. I know I already have I have it most worked out. So we got 8, 5, 5, 0 right there. There's no 9. So we got 8 plus 5 is 18. Uh-oh, look right here. 1 plus 8 is 9. So we're going to leave that out. Once you add that 9, it's gone. So 6, 8, 8, 9. Now that equals 9. So 6 plus 8 plus 8 plus 8 equals 30. So we're going to do 3 plus 0. It's right there. All right, let's look right here. We got 2, 5, 2, 5. No 9s, but let's watch. 5, 6, 7, 8, 9. So we took those out. We moved the 5 over. So here's the 5. Oh, look right there. I see a 9. We got to take the 9 out. 6, 7, 8. Nope, not 9. So we bring it over. We're supposed to put 6 plus 2 right here. So I put 8 plus 0 because I already went ahead. So 8 got moved over. So when we do all that, See, this cancels out. We have these 16. We divide it down. Look, we get 4. So here's our 4. Okay. Then we come to our answer down here. We have a 9. We got to take it out. So then we add. We got to look. Let's see. 1, 2, 3, 4, 5, 6, 7. Nope. 8, 9, 10. Nope. So we added all those together and we got 15. Now 15 is made by 3 and 5. Both are prime numbers. So 3 is our number right here. They do not match up. 3 and 4 do not match up. So we went ahead. We add them together. 2, 3, 8, 9, 2 is not the correct answer when you add it up. You can use your calculator. You can use mental math. Whichever one you would like. I typically use my calculator to make sure I'm extra correct. But when I added it up, it was 23992. See? Yeah, try to get you right there. Okay, let's look at C. Okay, we got 78362 minus 3674. Okay, and they're saying it's 74678 is the answer. Okay, guys, we're gonna cast out our 9s. So we look. Do we have any 9s? Nope. 6, 7, 8. 6, 7, 8, 9. Those 2 are gone. Then we look at 7, 7, 8, 9. Those are gone. 6, 7, 8, 9. That's gone. 7, 8, 9. That's gone. The 8 is supposed to be over there. Sorry, guys. Okay, then we look over here. 7, 8, 9. 6, 7, 8, 9. So those 2 are gone. And we got 7 plus 4 is 11. We do 1 plus 1 is 2. You move it over. See, and then we should have an 8 right here. Sorry, 8, 9, 10. We should have a 10. 1 plus 0 is 1. So it'd be a 1 right there. Okay, look over here. Do we have any 9s? No. 6, 7, 8, 9, 10. Nope. None, none of those are going to equal out. So 7 plus 4 plus 6 plus 7 plus 8 is 32. You're going to separate out. 3 plus 2 is 5. So it's going to give 5. And this is going to leave you a 1. The 3 is wrong. Sorry, guys. I just realized that that was supposed to be an 8. I was doing this slide really quickly. This one is supposed to be an 8. That's supposed to be 8. So it says cast out the 9, show there is an error. Okay, so we're going to have right here, we're going to have 5, and that's going to be 1. Correct answer is 74688. It is. Okay, let's look at our last problem. 377 times 620 equals 209940. Let's see. Do we have anything to cast out 9s up here? 7, 8, 9, 10? No. 7 plus 7 is 14. We know it's not going to cast out a 9. So we got 3 plus 7 plus 7 plus 7 equals 17. 1 plus 7 equals 8. Yay, not a 9. Okay, and then we come over here, 6, 7, 8, not a 9. So 6 plus 2 is 8. We have 8 right there. Then we look down here. Do we have any 9s? Yes, we do. We take that one out and that one out. Let's see, 4, 5, 6, doesn't equal 9. So 2 plus 4 is 6. Okay, so we're gonna bring this down to 4 times 2, and 4 is our remainder up here. And then down here, we're gonna bring our 6 down to 3 times 2 and our 3. And so when we multiplied that out, it came to 233,740. So we know that wasn't right and they didn't match. So we're gonna go to our next slide. And question 3. Okay. Oh, this is gonna be a fun one. It looked hard when I first tried to solve it, but then I realized what it was and it was really easy. And I hope you guys find it easy and fun too. The color rods show here are 1 centimeter square, length 1 centimeter, 2 centimeters, 3, and 10. Goes all the way to 10. We say a rod measures another rod if a n number of the first rod places end to n are the same length as the given rod. Demonstrate part A through G. Okay. Here's our little rods. Aren't they cute? I had fun with the colors. So you got all the way to 10. We start at, we start at 1 centimeter. We go all the way down to 5. And then we got 6, 7, 8, 9, 10. Okay, here's our first question. Show which rod measures the end rod. Guys, this is really simple. All you have to do is put your numbers out there that multiply for 9. So you're going to do like your factors. You're going to have 1 and 9. And then what's the next number that's 9? We have our next number is 3 times 3. So that's how we got 1, 3, and 9. We'll measure the 9 rod. Okay, let's go to the next one. It says, show which rods will measure 6. Again, we're going to do the same thing. What gives us 6? We're going to do 1, 6, then we'll do 2 and 3. And look, there they are. It's just that simple. I didn't think it was that simple until I read the stuff. It really is that simple. Okay, it says use part A and B. Okay, A and B. Show the greatest common divisor. Show the common divisor of 9 and 6. Okay, guys, look. They both have a 1, but it's not big enough. They both have a 2. No. They both have a 9 and a 6. No. Okay, so it's going to be 3. Place the 10 rod and the 8 rod end to end to measure 18. Recall that a train is formed when one or more rods are placed end to end. So guys, look what we're looking at. 18. The 8 and the 10 messes you up. Trust me, I started reading, I was like, oh, I gotta do all that. Nope, you need to do 18. So what makes 18? 1 times 18 is 18. 2 times 9 is 18. 3 times 6 is 18. So here are your numbers. You just put them in order. Okay, it says, show all the lengths of the rods of the trains will measure the 18. Look, guys, you have the answer right there. All you have to put them down here. Because you already did side to side. You know what you're doing. Okay, it says, demonstrate how you might use these color rods to demonstrate the notion of greatest common denominator, GCD, to children. Okay. It's really easy because all you're really doing is you're multiplying. You're great. So the GCD of two numbers R and S is the length of the longest train or rod that will measure both the R train and the S train. So you just have to put them together. Simplify it out. It's not that hard, trust me. Once you realize how to do your LC, your least common denominator, you're good to go. Okay, now we're going to go to question 4. Okay. Okay, it says the LCM. See, we're doing the same thing over here. Demonstrating the table. Here's our table. Write in the following. Factors out any prime divisors. I'm having fun with that word. Divisors of one or more terms and replace each term containing the prime factor by its quotient. Continue until the last row contains only district prime numbers and ones. Then multiply the extract primes and primes in the last row to obtain the prime power form of LCM. The method works equally with any numbers and terms. This is what they're asking for right here. That is what all that means right there. Okay? Okay. Look, we're going to sit here. I sat there and multiplied these things out, and it was, sorry, how did I explain? It was a nightmare. So I found to do it this way. Okay, 48. What goes into 48? You got 2 and 4. Then what goes in 24? You got 2 and 12. What goes 12? 2 and 6. What goes 6? 2 and 3. Okay. Then you come to 25. What goes into 25? 5 and 5. Go to your 65. What goes 65? 5 and 13. That's it. Now we're going to bring them over. You got 1, 2, 3, 4 twos. You put them right there. Make sure. Okay. Our next, we got 2 5s. Oh, wait. We have a little 3 over here. We got to make sure we get in order. Here's 1, 3. We got 2 5s. 1, 2. Because we have 2 5s, this 5's already counted for and it's already divisible by. All we have to do is bring over our 13. Then we multiply. And we get 15,600. And then here's how you do it. 1, 2, 3, 4. You 2 the 4th times, look, you only got 1 3, so you put a 1 up there right there. And then you times 5, and you put a 2, because 1, 2, you got 2 right there. And 13, you got 1, and there's your answer. Let's do the next one. 40, 12, 44, 363. Okay, 40, 4 and 10, 4 is 2 and 2, so we're done. There's our primes. 10 is 5 and 2, there's our primes. Okay, 12 is 2 and 6, 2 is prime. 6, 2 and 3, that's prime. Down to 44, you got 4 times 11, 11 is prime. Bring it down, 2 and 2 for 4. 363, 3 times 121, 3 is prime. And then 121 is 11 times 11, and they're prime. So what you do is you bring down your 3 2s. You don't have a 3 yet, but you do have a 5, okay? Since you already have 3 2s over here, you don't have to have any more 2s. 1, 2, 3, 1, 2, 1, 2. Yep, make sure I had enough 2s. 2, 3. I might have too many 2s. 1, 2. Nope, there's 3 2s. That confused me because it was right there. Yeah, we have to have 3 2s, so this won't be divisible by it. But we have 2 2s already here, so we don't have to bring those 2 down. There's 2 there. They're already divisible by it. So then you have 5. You brought your 5 down. You have your 3 from over here. You brought 3 down. You have 1 11. Bring it down. But there's 2 11s over here, so you got to bring 1 down. So you got 2 to the 4th, 3 to the 1st, 5 to the 1st, 11 to the 2nd. And here's your number you get. And that's what they're asking for. Here's our last one. We got 250, 28, 44, 110. Okay, we're going to do the same thing. 250, 2 times 125, 2 is divisible. Bring it down. 5 times 25, 5 is divisible. They're primes, sorry. These are primes. Okay, 5 times 5. Okay, so you bring your 2 down. And you have 1, 2, 3, 5. You have to have 3 5s, so it can be divisible by this one. Okay, you have 2 2s, so you have to bring a 2 down. You have a 7 right here, so it's got to come down. Got 2 2s, we're already divisible there. This 11 from our 44, sorry guys, 28 is 2 times 14. Bring it down, you get 2 times 7 is 14, those are primes. 44 is 4 times 11. 11 is prime. 4, you bring your 2 2s down. Got 110, 11 times 10. 11 is prime, and 5 times 2, so you got to bring those down. When you bring them down, it's going to look like this. You only need 111 because there's only 1 in each. So you got 2 square, you got 5 thirds, you got 7 1, you got 11 1, and here's your answer. And this is how you write that right there. Okay, here's question 5. Okay, aren't those cool? Okay. It says, in a machine gear with 48 teeth is engaged with a gear with 84 teeth and with a teeth A and B on the same large gears, respectively in context as shown. Demonstrate how many more revolutions, that means it goes around, I'm trying to show you, it goes around, okay? The small gear will have to make before A and B are again in the same position, okay? Here are steps to help you solve. Okay, the first step in solving the problem is to find the LCM of 84 and 48. Okay, and that's what we did. 84, 2 times 24, 2 is prime, so leave it. You got 2 times 21 for 24, leave 2. 21 is 3, 7. Those are prime, I circled them because they're prime. 48, you got 2 times 24, circle the 2. 12 times 2 is 24, you circle the 2. 6 times 2 is 12, circle 2. Got to come down one more step, 2 times 3, you got that one. Okay, then it says the next step is to bring down your prime numbers and multiply them. Okay, let's do that. Okay, so we have 2 fourths, 1, 2, and then so we only need 2 more from this problem. We only need 1, 3 because it makes it divisible by both, and we need 1, 7. So 2 to 4 times 3 to 1 times 7 to 1 equals 336. Okay, now we're going to do the next step. The last step is divide by the smaller gear number, and it will give you your answer. So we divide it by 48 because 48 is smaller than 84. You see it's a little lower gear. And that gave us 7. Okay, now it's time for question 6. Our last question of the night. Demonstrate how to create a magic square using the following integers: -7, -6, -5, -4, -3, -2, -1, 0, 1. Now create a magic square, your own demonstration, how you decided on the numbers and the position of the numbers. Okay. Okay, I want to tell you guys what a magic square is. Some people do not know what a magic square is. So we have magic square is a square arranged so that the numbers in the row, the numbers in all the rows and all the columns and the two diagonals have the same number. So what you first need to do before you even put numbers in here, you need to know what the rows are going to add up to. So how do you do that? How do you find the sum? Is to add up all the integers. So we have all of our integers and they equal -7. Now we have 1, 2, 3. We have 3 rows, so it's going to be 3x. So it says then divide how many rows? So 3x equals a -27. You divide both sides by 3, getting your x by itself. X came down. -27 by 3 is -9. So we know all the rows going this way, this way, this way, this way, that way, all of them have to equal -9 when you add them up. So we were already given 0 and 1. So we're going to start at the bottom. It's easier to do this way. If you don't, you get a little confused and you run into stuff. So we start with a -2, -3, -4 equal a -9. Okay, now we're going to do the top row. So 0 plus -5 plus -4 is -9. Okay, then we have this one. 0 plus -7 plus -2 is -9. I'm also completing this row at the same time. -7 plus -3 plus +1 is -9. Okay, then we have our bottom one. -2 plus -1 plus -6. I'm sorry guys, I thought that was a little bit darker. Is -9. We go this way, -4 plus 1 plus -6 is -9. You do the same thing. -5 plus -3 plus -1 is 9. We went down. We went this way. Then we went this way. 0 plus -3 plus -6 is -9. So you want to make sure all of these equal a -9. That is how you do a magic square. Okay, that's the end. If you have any questions, feel free to leave comments on my video. Okay, thank you guys. Have a good night.